Good afternoon, ladies and gentlemen, and welcome to Math Mountain, Episode 3, where we'll be talking about algebraic approaches to limits. When finding limits algebraically, we can use three basic steps. So the three steps to finding the limit as x approaches a of f of x algebraically are first, just plug in a. If you get a finite answer, then you have your limit. Second, we want to remove any discontinuities or any holes. So refactor and eliminate common factors, top and bottom, and then repeat step one. Plug the value of a in, and if you have a finite answer, you have your answer. If step 1 and 2 don't give you a limit, then the limit is going to be either infinity, negative infinity, or a limit does not exist. And we'll talk more about that here in a bit. Our first example today is a parabola, x squared minus 2x plus 3. We'll be finding the limit of that function as x approaches 1. So applying step 1 from the previous slide, we can plug in 1. So f of 1 is equal to 1 squared minus 2 times 1 plus 3. Let's see, that's 1 minus 2, that's negative 1, plus 3, that's 2. So we can say then that the limit as x approaches 1 of f of x is 2. To help reinforce some of the graphical concepts that we talked about in the previous episode, I brought the graph of the function in as well as the table, and you can see both graphically we are approaching 2 from the left side and the right side. And you can see in the table as we get closer and closer to 1, as x values get closer to 1 from both the left and the right, we are in fact approaching 2. Our next example is a rational function, quantity 2x plus 5 over quantity x minus 3 as x approaches 2. So we're finding the limit of that function as x approaches 2. So let's apply the first step of our 3 steps. Let's go ahead and plug 2 into the function and see what we get. So we get 2 times 2 plus 5 over 2 minus 3. And that's going to be in the numerator, that's going to be 4 plus 5, that's going to be 9. And in the denominator, it's 2 minus 3, or negative 1. So that's negative 9. So our limit as x approaches 2 of f of x is negative 9. Again, let's take a look at this problem graphically, and we can see, well, we can't quite see, but it's down there. As we approach 2, our graph is heading down here, and it is in fact negative 9 at x equals 2. And you can see in the table we are at x equals 2 equal to negative 9. Our final example in this episode is to find the limit of f of x as x approaches 1 of the rational function quantity x squared minus 2x plus 1 over quantity x minus 1. So let's try step 1. Let's plug 1 into the function. So f of 1 is going to be 1 squared minus 2 times 1 plus 1 over 1 minus 1. And we get 0 divided by 0. And that is not defined. So we have to move on to step 2. So step 2 was to factor and cancel. So let's go ahead and factor. This is step 1. Now step 2, we'll factor and cancel. So let's see if we can factor x squared minus 2x plus 1. So let's rewrite that as, let's see, what is that? X minus 1 squared. And in the denominator, we have x minus 1. So we get cancellation there. And that leaves us with x minus 1. So let's now plug 1 into x minus 1, and we get 1 minus 1, and that's 0. So we can write this limit as the limit as x approaches 1 of f of x equals 0. One more time, let's bring the graph and the table in, and we can see that at x equals 1, we have a hole. Again, that's a removable discontinuity. Once we factored out the x minus 1, from top and bottom, we ended up with a line, x minus 1, where the function is not defined at x equals 1. But again, we're not finding the function value, we're finding the limit. In other words, what does f of x approach as x approaches 1? So again, look at the table. We're getting closer and closer to 1 from the left side, and you can see that we're approaching 0 on the right, or the y value is approaching 0. And on the right, as we get closer and closer to 1, from values of x greater than 1, our y value also approaches 0. So it all ties together. That's it for episode 3. Thanks for joining me, and I hope to see you for episode 4, where we'll be looking at some trickier limits, where we get into step 3 of our algebraic processes for finding limits.